Right. So my name is Jeff Steiner, and I'm a long-timer with NetApp. I've been here for, I think, a little over 15 years now. So my title is Principal Architect for Enterprise Applications. And informally, I'm the database guy. I'm not sales or marketing. I'm the engineering guy. And I get involved in really any product or feature enhancement that has any connection to a database. On the whole, that does mean Oracle databases because that's the big players. So just a little bit about my background. So I come from a long history of people being very technically precise, and you will see that in this presentation. So I actually came to NetApp most recently from Oracle itself, where I managed all of the Oracle retail environments, ranging from the on-premises development environments, routine file sharing, right up to the critical customer-facing hosted stuff that was out in the Austin data center. So I've seen the whole spectrum. I've selected storage systems. I've selected fire suppression systems. So it's been an interesting time. Also, I am a licensed attorney in the state of Minnesota. So maybe someday we'll talk about Oracle licensing policy, but that's too much for this session. So this presentation it's kind of an odd one for me because I'm not really talking about NetApp. This is all based on a sort of a speech that I give to a lot of customers whenever we're facing a complicated project. And it's about understanding what you actually require for your database environment. Too often people are leaping to the PowerPoints and saying these IOPS are more than that IOPS, or this is new, or someone recommended this, and we don't really know where we're going. And if you don't know what problem you're trying to solve, it's going to be kind of hard to try to solve it. So some of this session will go very low level technical into databases, but the principles really do apply everywhere. And this is a good example of how IT can be a lot more complicated than it may seem, but everyone should understand this. And some of this presentation is actually drawn from something I presented at Insight, where it really was directed at everyone from the low-level DBAs to the CIO and DBA managers. So just a real quick agenda of the things I'll be covering. First, a few words on historical database sizing, and then modern database sizing with SSDs, an overview of what is database I/O, and then the Oracle AWR report and why we love these so much. And the reason is really that it tells you everything. And then the common bottlenecks that you have in an IT infrastructure like CPU, IOPS, latency, bandwidth, and the all-important logging. And I'll say it one last time, a lot of this really is Oracle-centric. I'm using Oracle technology, but the principles absolutely apply to any relational database, and they apply to most IT workloads. So historical database sizing, and I'm completely serious about this section. This is jumping back maybe 10 years, where we had these things, the spinning drives. And everyone knew that an IO-intensive workload would be running on spinning drives, which would hit the wall at around 120 IO operations per second. As a side note, that term IOPS is dangerous. It doesn't quite mean anything defined. Different vendors use it in different ways. I'm just talking about database blocks per second, file reads per second. After 120, it's just going to fall apart. It can't go any faster. Now, we knew this. And this is how we would do storage sizing. And I could name 100 companies that are huge worldwide names where this is how we size their database storage solution for their databases. So the storage vendor comes in and says, hi there, customer. How many IOPS do you need? And everyone always has an answer. Might not be the right answer, but they had an answer. And they say 10,000. And then we say, so 10,000 IOPS and 120 IOPS per drive. I need to sell you something with about 83 drives. So, hey, buy one of these. And it really was that easy. And it would have been nice if we could go deeper, but when all you can sell is these mechanical spinning drives with these very rigidly defined limits, that's it. And sometimes we ended up selling just racks and racks and racks of drives. Sometimes it would be a handful of drives, but honestly, we were selling you drives, and the storage controller had very little to do with performance back then. And then came Flash, and everything changed. So if you buy one of these things, it's good for around 100,000 IOPS before you reach the limit. And obviously, there's newer drive technology that's even faster. Now, it's not possible to have in a storage array with one drive that's going to be able to push 98,000 IOPS. But the point is the drives are ridiculously powerful and they're not the limitation anymore. So now what do we do? And when all-flash first arrived on the scene, what happened was almost no one needed it because until that moment, they couldn't have it. You don't have a CIO saying, hey, I want 1 million IOPS at 500 microseconds of latency with spinning drives. You can't have it anyway. But as this became affordable and widespread, people very quickly found all sorts of use cases and it expanded. So when someone says database now, we have no idea what sort of performance requirements they're looking for. It's huge, huge span. For a regular database, like real enterprise opportunities that I get involved in, the sizes of the database or the collective databases are usually somewhere between 200 gigabytes and 800 terabytes. And the latency requirements are between 120 microseconds and 10 milliseconds. The IOPS requirements are anywhere from 2,500 to 800,000, and the bandwidth requirements is usually around 100 megs, but it can be 32 gigs. And that's why it is so important to understand what you're asking for. Don't just simply say IOPS, because the IOPS are faster these days, they're cheaper, the latency matters more, and the range of the requirements has expanded more. And think about what life would be if you worked for Ford and you have to be able to have a customer walk in and ask for anything between 200 and 800 passengers in the new Ford Focus. Oh, by the way, I want the top speed to be 10 to 8,000 miles an hour on the outside with a towing weight of maybe 1,000 pounds, maybe 1 million pounds. I mean, that's what we're facing. We have to sell these products that can meet this incredibly wide range of requirements. So the question here is really, what do you need? So there's three basic types of performance when you're talking about really any application, but especially a database: IOPS, latency, and bandwidth. And odds are one of them is a limitation. So if you're trying to upgrade storage, don't worry about the IOPS or the latency if what you have is a bandwidth problem. If the problem is latency or bandwidth, if the problem is IOPS, don't worry about latency or bandwidth. And likewise, if what you have is a latency problem, don't worry about bandwidth or IOPS. Find what you need to do. And most importantly, don't upgrade or troubleshoot storage if you don't have a storage limitation. I'm sure the NetApp sales teams would be perfectly happy to take your money if you really insist. But a lot of the time, we can prove that you don't have a storage limitation. The limitation lies elsewhere, so why worry about storage? I mean, I guess if what you have is end of life, you have to do something and it's worth future-proofing. But don't expect the storage vendors to help you out of a performance problem. And absolutely don't size for a flawed storage configuration. Those last two things I see all the time, where someone gives me an AWR report and says, my database is too slow. And it plainly shows a CPU limitation. We can upgrade, we can downgrade. It won't do you any good. Or we see something massively wrong where, I don't know, it's a failing fiber channel port, and there's no reason for you to buy an entirely new storage system. Just fix the port. So a brief overview of what is database I/O. And this is not as complicated as it looks. There's going to be a lot of boxes here. Picture what we have to do if we're going to double someone's salary. So you talk to the database, and the database says, okay, what am I getting paid now? And it's going to look up your name in an index. And DBAs live and die about indexes, and it's pretty much what you think. It's like the index in the back of a book. You don't read the entire book trying to find the part that you want. You just jump to the right part in the index. So you look up your name in the index, a couple little reads, small number, random block reads, and then you look up your current salary. A few more random block reads, no big deal. And now we multiply the salary by 2. We're going to get rich now. Now that's a change to one of the database blocks, but we're not going to update the database yet. We're going to log it because we don't want to lose our salary increase. We want to make sure that it happens as quickly as possible and it's persistent and it never gets lost. The quickest way to do that is put it into the logs. That's why DBAs are so obsessed about the logs. Every change to the database starts with a log write. Now, eventually, you update the database. And that happens a lot later. And this is an example of how customers start to go wrong because that happened later. Our salary increase already occurred. That, if we make the latency of the data file writes faster or slower, doesn't matter. It's a background operation. Well, it can matter in extreme cases, but on the whole, it doesn't matter. And then the last thing you have to concern you about is what happens when we want our OPEX report of all the expenses across the past month. How do we do that? Now we have to read all of the data, start to finish. That usually happens 128 blocks at a time. That's a 1 megabyte read. Right there, that should make you start to think about the term IOPS. Some of these IOPS were tiny little 8K reads to find out what our salaries were. Some of them were 1 megabyte reads to find out what large numbers of people's salaries were. So it's not, a block is not a block. IOPS doesn't necessarily mean anything. As a rule of thumb, and this is really broad, this is what you probably want. The data file random reads, which is called a DB file sequential read. Here's an example right away of how this gets, Oracle is not making this easier for us. A random read is a sequential read. Depending on who you ask, it's either a sequence of random reads or a read from an indexed sequence. But either way, surprise, sequential IO is random IO. If you have spinning disk, and a lot of people do, I mean, you could run payroll on spinning disk 15 years ago. You can still do it now. It's probably not worth the money. You might as well just get all SSD, but some databases are huge and not performance intensive. So spinning disk reads, you should have around 5 milliseconds. If it's an SSD, it should be between 250 microseconds and 1 millisecond. If it's not, something's a little fishy. Your storage array is overheated, the configuration's wrong. Now, data file sequential read. This is what Oracle would call a direct path read or a DB file scattered read. Another fun terminology detail there. A sequential read is scattered. So sequential is random and scattered is sequential. As a general rule, those should be around 2 to 10 milliseconds. It's going to be higher. This is another example of where customers get things wrong, where they say, I want all the latency to be sub-millisecond. We can give you sub-millisecond latency for a tiny little block read. You are not getting sub-millisecond latency for these giant 1 megabyte sequential operations. It's not going to happen. Now, the log writes, I think people spend way too much time worried about. Yes, they need to be logs and writes need to be very, very fast, but that's an easy type of IO to handle. It's just not a concern on any modern array. You should have latency between 100 microseconds and maybe 5 milliseconds. But that also varies because the size of the log writes vary. Might be a tiny IO. It could be many megabytes. So it varies
Jeffrey,
a lot. Yep.
I've always been of the opinion that log writes are sort of the gating element for database performance. And with log writes, when they don't perform well, the whole database sort of tanks as well. But you're indicating you don't think log writes are an issue.
Log writes need to be fast. You do want the lowest possible latency, but from a storage point of view, if you are doing a log write to really an array from anyone, you are almost guaranteed to be committing that write to some sort of solid state cache device. In the case of NetApp, it would be NVRAM. So that's battery backed DRAM. If there's not a lot any vendor can do to make that particular IO faster. It's sort of physics at that point.
But the NVRAM, of course, is some limited amount of space. I don't know if it's a gigabyte or a terabyte, but at some point that log needs to be flushed elsewhere.
True. But if you actually look at the math, the size of your write cache should never matter. It's actually the speed of the backend disks. And if anyone wants to have a long explanation of why that's true, I've got a much longer detailed explanation. Basically, what happens is with ONTAP, and other vendors are kind of similar, but ONTAP is a little bit unique because the size of NVRAM is rather small because it doesn't need to be. What we're doing is accepting the writes almost instantly as it goes into NVRAM. And then the CPU will line up the changes in RAM, calculate the parity, and write everything as a full stripe. Let's say that we did make NVRAM 10 times bigger than it is now. It actually would not affect performance because the write commit is acknowledged as soon as it's in NVRAM. As long as that data can be written out to the backend disks fast enough, the size of NVRAM doesn't matter. And this is where with spinning disk, it did matter, because if the backend disks got incredibly slow, especially if you were running some sort of IO intensive report, the backend disks get busy and they're no longer able to receive the data being flushed from NVRAM, and your log writes could suffer. And other vendors would have similar things. I mean, the logic might be a little different, but the idea is the same. But if you have bad log latency, especially these days, that's almost a guarantee there's something misconfigured, or the whole array is just utterly overwhelmed. But it's not really going to be you don't have to zero in on the logging per se. If you have a logging problem, there should be something in bright neon indicating a problem on the array. And the last section on this is data file random writes. We really don't care about that because that's background activity. There is actually an exception to that, though. It's connected to the log writes. If you are killing the overall array with I/O, and if you can't write data fast enough, then you can't clear buffers for the database to read new blocks. So in effect, if something goes horribly wrong and your random write latency goes through the roof, that can indirectly affect your random read latency because there's nowhere to put the data that you're trying to read. It's very unusual, and the AWR should look like a mess if you're in that situation. But on the whole, it doesn't matter. High latency, low latency, it won't affect the database performance from the user point of view. Now, AWR is the automatic workload repository, and you'll hear DBAs talk about AWR a lot, and they've got their own uses for it for looking at queries, but for us, I want the storage metrics, and it's beautiful. It's got every little detail with histograms and large block and small block and reads and writes and foreground and background information. It's everything you'd possibly want from a storage vendor. Anytime I can get that for a sizing exercise, I will. One of the coolest things I ever got was a 6-month AWR dump of many, many gigabytes of all the performance data for a certain European country's post office. And we mapped everything that happened over 6 months in terms of I/O. And we can be absolutely certain that our sizing is correct. And I really think that that is critical these days, that to use AWR for database sizing, use real numbers, because like I said, the requirements vary so much and the data's there. I mean, if you don't do this sort of an exercise, like I'm describing in this presentation, you will either end up overpaying or you will end up undersizing, and you'll run into problems down the road. So the AWR is just a little set of tables inside of Oracle where it's keeping a record of what's happening, and that includes the storage metrics. By default, it is making a little sample record every hour, and it will keep them for 8 days. So at the default, you'll have 8 days worth of beautifully detailed performance data. We also love this for troubleshooting too. If someone says the database was slow last Wednesday, show me. Give me the report from lunchtime last Wednesday and let's see what happened. Some customers actually increase this to 15 minutes, and they sometimes increase the retention way higher. And as I said before, the performance requirements are going to vary widely, and you have the real data, so why guess at the storage requirements? It's a little more awkward to do this sort of thing for other databases like MySQL or Postgres, but all databases have some degree of this capability. Now here's where this presentation gets a little bit harder to kind of explain. What I've structured this as is some examples of what is an AWR and what sort of information do we get and what does it tell us. So when you first start looking at one of these AWR reports, it's going to have an information of when it was taken. They call it a snapshot. So this sample AWR starts at snapshot 20145, which start time is 1 o'clock on 22nd of July, and then it ends here at 2 o'clock. And I can see there are 2 instances. This is a 2-node rack cluster. Most importantly to me, elapsed time of 59 minutes. This is a 1-hour report, so it's an average of what happened during that hour. There could have been significant peaks during the hour. Maybe it was consistent. All I know for sure is that it's an hour, and that's reasonably granular. Don't do this. We have way too many customers that will size their efforts based on an IOPS from some massive report over many, many months. And the average speed of my car is about, well, I'm actually in Florida right now on a small deserted island. So the average speed of my car right now is basically 1 mile an hour because it's parked all the time. Same thing with the database. Don't average your performance need over a huge amount of time because the peaks and the valleys get lost in the averaging. So don't do this. Don't do it internally. Don't give it to your vendor. When are you going to actually find the right data? How do you know what to pick? This is kind of like guessing, and this is what I say to customers. Pick a few times when you know I/O is high, or users are complaining, or users just wish performance is performance was better. And then collect it and make sure that you got it right. Sometimes it takes 4 or 5 times to get the right AWR report. And then start the analysis. What are my IOPS needs? What are my latency needs? What are my bandwidth needs? Those are the 3 things that we look at from storage. Do I need to do anything with IOPS? Do I need to do anything with latency? Do I need to do anything with bandwidth? Do I have problems? If I don't have any problems, I'll just size for the peaks and maybe add a little padding. If I have problems, where's the problem? You can also ask a little more specifically, like, do you know when IO is high? Do you have specific times? Are there IO intensive reports that only run at night, maybe the end of the week, end of month, end of quarter? Do you have a specific query that you know needs to run faster than it does now? We've worked with AWR reports that are like 8 seconds in length. What are your backup windows? Don't necessarily size for backup IO. That isn't, as long as you're making your backup windows, that's okay. But if you size, assuming that your backup IO is going to run 24 hours a day, 7 days a week, you might be oversizing. And then, as a rule, give us a maximum of 60 minutes elapsed time. That's the broadest interval we should look at.
Hey,
and
Jeffrey,
at least think, sorry.
So what about, like, NetApp's famous for snapshots, and most of the other storage vendors now have that sort of stuff. Where does that sort of figure into this? Oh, he's got it right here. I get it.
Snapshots in terms of affecting performance?
Data, copying the data, point in time snapshot of the database. It's not necessarily a backup per se, but it's a copy of the database.
That's one of the reasons why you really have to pay attention to the backup windows, where we do have sizing intervals. The word snapshot is used in 2 ways here. An AWR snapshot is, I guess, the same idea as a NetApp snapshot, but it's recording the values of the performance counters. For NetApp snapshots, one of the key values of our snapshots is that there isn't a performance impact of it. Just take a snapshot. Actually, honestly, ONTAP is sort of taking snapshots anyway on a regular basis. It's part of its internal checkpoint process. So snapshots happen all the time. If you want to create a snapshot, what you're really doing is retaining a snapshot that was sort of created during the natural operation of the database. So for us, that doesn't have a performance impact. And one important thing about snapshots is that will erase your backup IO. If you are sizing we've had a lot of customers where the biggest problem they had was the backup IO. And when we got them over to snapshots, the result of that was that backup IO disappeared. If you aren't paying attention to when the backup IO is happening, you might be sizing way too big. We've had controller models drop 3 or 4 levels, like going from modern day terms and like an 800 down to a small A220, because with snapshot-based backups, you don't have to copy the database over and over.
Jeff, I have a couple of questions here, because the discussion is really interesting, but you're focusing a lot on a single workload for a single array in this case. Okay, so like a database insisting on a single FAS or AFF array or whatever it is. The problem is that 99% of the customer and I are trying to consolidate several workloads on the same machine. So you have a lot of contention also in the backend. I understand analyzing the single workload, but you should take a look at all the other things that work on the same array. And
that does complicate things. And I actually said in a presentation this morning that things used to be a lot easier 15 years ago, because if you had one important workload, database or otherwise, it usually got its own array. And these days, no one does that. You really want to consolidate as much as possible. There's no reason to. If a modern array can handle 1 million IOPS at well under a half millisecond of latency.
To my point, so we are talking about a single workload, but actually there is this blender effect all over the place. And so even if I spend a lot of time, why don't I throw some more, Optane or flat NVMe or whatever to my array, and that's it. Again, this is I will advocate here, and I'm not trying to diminish what you're doing. I'm saying, isn't it too much of a work to ask all these questions to the client and understand all its needs on a single database when he has 20 databases, VMware, and maybe other application that has totally different workloads, and of course, he doesn't want 20 arrays.
It absolutely is complicated. So most of this presentation is based on the conversations we have with real customers, where usually we'll walk in and the databases in scope are between 1 and 10. Like, those are the really important ones. And those are the ones that usually they know are responsible for the most IO. And then you do often have the 30 or 40 other databases that are used for development, and they know that they have lower IO requirements. And honestly, the usual way of doing this, and for better or for worse, is we will get the AWR for the big hitter databases, and the DBAs usually know what times to generate that data for, and then they guess at the others. And if you know the production database is pushing 100,000 IOPS at peak, it's unlikely that development needs more than 25. And if it's worth it, there are things like products like On Command where you can get more detailed statistics from a large footprint, but it gets difficult because, among other things, how do you know that IOPS was the issue? I mean, just knowing the total IOPS that you need isn't the whole story. I mean, there's no doubt about it. This is absolutely complicated. And we do have a lot of customers that just buy an excessive number of arrays. The best way I know is really to divide it between the heavy hitters and the less IO intensive workloads. And you can, as an absolute basic step, you then start planning your QoS limits, where if you know that the controller system you've got is good for 1 million IOPS, you've got 500,000 IOPS worth of production databases to service, that leaves you a lot of extra safety room. And then we'll start applying the QoS limits. We'll monitor. We'll see which databases are pushing the limits, which ones aren't, which ones are more active than we thought, and just grow over time. And I really do agree. I wish there was a better way to predict this, but it's hard. And then there's other factors too, because when we're involved with a storage project, there might be new database servers being purchased, and the RAM is going to be increased, or new workloads are going to be increased, and then the whole pattern is going to change as well. So my father was a longtime computer scientist, and I've kind of referred to myself as a computer artist. Sometimes you can't quite explain how you architect these things. You just have to talk to the IT staff and get a vibe of what they're trying to accomplish, where the problems lie, get the numbers where you can, but there's a limit to how precise you can be.
No, we totally agree on that. And sometimes it's also the database. You have to purchase additional features to make it fast. I mean,
I've actually been telling partners a lot over the past, honestly, 5 years, if you really want to be useful to your customers, take 1 or 2 of your best guys and send them to SQL school, because for most of my history in the IT world, you could spend your way out of a database performance problem. Maybe you could make the queries better, but it was just easier to buy faster disks. And that just flat out is almost never true now. The only way you're going to really make a difference is to make the queries better. And it happens a lot.
Yeah, so when we talk about performance and databases, I mean, I would say a couple of years ago, it was heavily focused on storage. Nowadays, with the columnar databases and the fact that compression becomes a more interesting piece, I would even dare to say that performance today is a combination between selecting your compression level and your ability to compress in your I/O, right? But the goal of the compression is to limit the amount of I/O you do, but then at the same time, you're kind of pushing your bottleneck or your performance bottleneck to CPUs. Do you see the same thing where when you go in that it becomes a combination between CPU and storage, or do you still think that most of your customers are heavily focused on the storage piece?
I think an awful lot of them, most of them are definitely focused on storage, and I'd say only about half of them should be. There's always value in getting the latency better, because all the users will benefit and the whole end user experience gets faster, and you can do things that you couldn't do before. But if you're half of the AWR data I see coming in, I have to find a creative and diplomatic way to say, you do not have a storage issue. If you want an A800, you can buy an A800. It would make no difference if you went to an A220. We could dig up something old from the closet, and as long as it's all flash, it won't make a difference. And I will point, like, here's your AWR report. There's the line. There's the query. You can see literally 98.3% of your database waiting is for this query logic to complete. And I'm not a good enough DBA to know what to do. I've written enough queries in my time to know that the difference between a well-written and poorly written query is night and day. Like, I will reorder some things in some of my own work, and a 2-hour operation becomes 2 minutes. But so I know it can be done. But more importantly, from a storage point of view, I'll know that we can't help anymore, like, not for this workload. And sometimes it's hard to break people of that habit of believing that you can spend your way out of it. And that's what I'm telling the partners: learn how to write the SQL better. And it seems to me like most people, it's harder and harder to find people that can do that on staff at customers. There's more people that will open a support case to get answers from Oracle, and they're not always the best answers. I mean, and nor should you expect it either. Oracle support is not Oracle consulting.
Jeff, just to add to that as well, do you still find that tends to be the general route out, because actually re-architecting something like an Oracle database is such a big challenge that actually trying to spend your way out of it with a with a brand new all flash array is quicker, cheaper, and easier?
Well, that was the case for a long time, and it's, in a way, Oracle Exadata is a similar situation where, yes, an Oracle Exadata will run a lot of databases a lot faster than they are now, not because it's Exadata, but because it's newer and it's going to be configured correctly. And it's getting harder and harder. As everybody's moved to modern hardware, you just can't throw hardware at the problem. And we do see customers that are sometimes sure that improving storage performance will help their database workload. And we can see it's just not. And that's the value of the Oracle AWR. And I wish there was better ways to get this from other databases. Microsoft SQL Server is pretty good, but I know there have to be a lot of other workloads where people are just looking in the wrong place. And also a big problem with the really big enterprise databases really are that the needs vary so much, where we'll have two customers that are in the same line of business. They describe a very similar need. They both think their databases is the biggest, scariest thing ever. One of them is a terabyte. The other one is 150 terabytes. I don't know why. One of them clearly needs maximum 10,000 IOPS. The other one is doing 250,000 at peak. There's no particular explanation for that either. Like, here's an example of something that I run into all the time. So I mentioned earlier, are you sizing or are you troubleshooting? This is taken from an Oracle AWR report. It's called the foreground wait events. Now, a wait event doesn't mean something bad happened. It means something happened. Oracle times everything. You're going to have wait events unless you turn the database off and don't do anything. If you see a log file sync wait event of 460 milliseconds, these are all real examples, by the way, and it's eating 40% of your database time, something is wrong. Don't size for this. Something is broken. You need to fix something. And we often end up with discussions where by the time we get the AWR, any kind of performance analysis, the whole sales process is well underway and there's other vendors competing. And for some reason, nobody's raised their hand and said, wait a second, this is not right. Another example where someone will say, my database performance is terrible. And if you see something like this, your database performance is terrible. But when you see this term GC, that's global cache. This is what happens when you have an application running on Oracle RAC that really should not be running on Oracle RAC. The various nodes in the Oracle RAC cluster are in a big fight with each other over the same data. This is from a customer escalation just about 2 months ago. We really do see something along these lines at least once or twice a week. And those are only the things that get escalated to me. Really good example of CPU. So this is this is the Oracle sales rep buys a Ferrari example. So this is what most databases look like these days. All right, so you look at, let's say that you come across this AWR and you see DB CPU, 82%. I must need more cores, or maybe I need more CPU. I need more CPU power because that's what's holding me up. And you might look at DB file sequential read, remember random reads, and I mean, can we do better? Sure, we could absolutely upgrade you to an A800 NVMe over fiber channel. That weight at these levels, that weighting would turn to 100 microseconds or so. So it would erase that storage event as a source of a limitation, but it's only 10%. So if I give you infinitely fast storage, your database might be 10, 15% faster. Who cares? Everyone looks at the CPU and they say, oh no, 82%. I need more cores. And this is what's actually happening. This, by the way, is the post office example. This is a 20-core system. It's 82% idle. What you're looking at here is a database server where one or two of the cores are running at 100% all the time. The other 18 cores are bored. They're not being used at all. Not only that, you're paying a lot of money for Oracle licensing and support for cores you aren't using. I see this every day too. So you can't spend your way out of storage on this. You need to find a better way to make that query run. And all this data is very easily seen in the AWR data. I actually do these workshops for storage teams and teach them how to work with the DBAs and translate a DBA performance complaint into storage metrics. An example of how IOPS are not necessarily IOPS. This database in this sample read about 50,000 blocks, but it did it with 1,500 IO requests. What it's doing is reading multiple blocks at a time. This is sequential IO. So if you tell your storage vendor, I need 50,000 IOPS, that's not right. This is not 50,000 IOPS. Strictly speaking, this is 1,500 IOPS, but that doesn't really mean anything for sequential IO. We only talk about IOPS, meaning small individual IOs. So if you're sizing this for 50,000 IOPS, you're going to buy more than you need. What you really need is bandwidth to meet these IO requirements, and you're not storage limited anyway. You're doing large block reads with a half millisecond of latency anyway. That's already great. This is what happens when you're hitting cache, by the way. So it's more complicated than it looks. You're CPU limited. You're not storage limited. In contrast, here's a light example. If we're reading around 5,000 blocks and we're reading around 2,000 actual read requests, that's a lot of random IO. There's some sequential IO in there, but the blocks that we're reading and the IOPS we're reading are closer to each other. So this is a small number. I would call this 5,000 IOPS. And if you're dealing with sizing for a large database environment, it's pretty quick to zip through the AWR reports and get this data easily. I mean, I wouldn't want to do this for like 1,000 databases, but we've certainly sized for 100 database workloads by just asking the customer to print off the AWR reports. I know it's a little tedious, but it's the best way to get the information. And here we've got DB file sequential read at less than a millisecond. And yes, it is 43%. So now we actually have a storage limited database, finally. Can we make this better? Some. This is about the best that you're going to do with an all-flash solution. If it's a brand new all-flash regular SSD SAN, I guess you can do better, but this is a case where you want to be looking for NVMe over fiber channel. You need to bring that latency down. The IOPS are nothing here. 5,000 IOPS. I mean, my phone can do 5,000 IOPS with a little chip inside of it. But getting better latency than 475 microseconds, that's a little harder. And of course, you still have DB CPU eating up a fair amount of time too. So don't forget the queries. Example of bandwidth, 68,000 physical reads, only 1,500 IO requests, moving about a gigabyte per second of total data. So that is actually suspiciously close to a, can be a 10 gigabit connection. So if this database is going too slow, do I need faster storage? Or maybe what I need is more network bandwidth. But this is absolutely not 68,000 IOPS. This is bandwidth. And same database, once again, it's mostly CPU limited anyway. Direct path read temp, 20 milliseconds latency. That means it's a large 1 megabyte block read. 20 milliseconds of latency is a bit on the high side. DB file sequential read, that one's much better. And then another example of latency. Now this is what we used to see all the time. And this was the gold mine type AWR that we would see, and I guess probably competitors too, when they're trying to sell one of the hybrid solutions, where if I saw this, that is 15 milliseconds is a busy spinning disk. And I know if I give this customer, if they have spinning disk now, if I give them Flash Pool, which was our initial hybrid solution where it's a little bit of flash married up to some spinning disk, I can probably erase this as a source of a performance limitation. I don't know how fast it's going to go, but it's going to go a lot faster. If I put this on all flash, it's definitely going to go a whole lot faster. So unfortunately, those days are mostly gone. Very few high I/O databases on spinning disk. This is, if we see something like this, and then we know that it must already be on SSD, there's limits to what we can do. I know these examples kind of get hard to tie together, but it really is when I look at this data, I really do sort of do the triple analysis where I'll say, okay, what is my IOPS situation? And what is my latency situation? And what is my bandwidth situation? And that's how we do the sizing. That's how we spot the storage problems. And then I will also keep an eye out for that DB CPU being the main problem with the database. And just as an example of where we can go, I mean, this is what we're dealing with. This is not an absolutely precise apples to apples comparison. These were from a number of different performance tests that were very similar to one another, from the low end to the high end. But the main point here is just look at the range of what you can do, and just look at the lowest level of a system. If you've got a NetApp A250 with a regular fiber channel, you've got 200,000 IOPS worth of performance potential. Go back 10 years, nobody was asking for 200,000 IOPS. There are countless big, important ERP databases that haven't really changed their business purpose in any material way. And they were doing fine with 20,000 IOPS because that's all you could do back in the day. And it seems almost weird that you should only have to spend a tenth of what you used to for even when you upgrade your storage array, and you get a huge performance and boost in performance. But that really is the situation we're dealing with. You can also see what the future of IOPS is going to do. I said earlier, when all-flash arrays first debuted, no one really needed them because no one had a business need for it. And when I speak, I'm almost always talking about the database niche. No database needed an all-flash array the day that NetApp first started selling all-flash arrays. But in 6 months, people very quickly went, you know what? I don't want a daily report. I want an hourly report. You know what? Let's restructure this. I want real-time information about what's in my supply chain and what I need to ship. And you can do that now. And we're in the same situation now with NVMe, where we're going to have these discussions all over again, because look at what it buys you. Same hardware. This is an Oracle database doing a roughly 75-25 read-write ratio. By simply changing the network protocol that you're using to access your database, for one, the latency plummets. You have to pick where in the curve, but we're modest levels. We're going from 300 microseconds down to a steady 100 microseconds. That really does allow you to do things that you could not do before. Plus, one array now goes so much faster. So we're going to go through this again, where we're going to have to sit back and wait and see what are people going to do with this new capability. If nothing else, you can certainly put a lot more work on a single storage system than you used to be able to. One last logging thing that I would like to bring up, and this one is really for the Oracle DBAs, the logging. A lot of times people will say, I have a problem with logging, and what they're looking at is log file sync. And look at this, 65 milliseconds for a log file sync operation. Is that a problem? Well, it's obviously the top weight event. It looks bad. But you are moving 40 megabytes per second, and the actual transaction that you're logging is 450K. That's a huge I/O operation. Now, that's not going to be sub-millisecond because that is so large. So your log file sync might be big, but that doesn't mean that you have a storage problem. And it doesn't necessarily mean you have a problem at all. I mean, that's your limitation. But look at the amount of data you are committing. And here's the really important one. If you see log file sync of 3 milliseconds, you might think that's bad, but take a look at the wait for log file parallel write. So if I have a database where I have a high wait event, that isn't the complete story either, because wait events often depend on other wait events. If you do a log file sync, that's not a storage operation. It includes a storage operation, but it isn't a storage operation itself. What it does as part of its operations is do a log file parallel write. So my logging operation took 3 milliseconds. 600 microseconds of it was the storage portion. Where'd the rest go? NetApp didn't lose that. And here's the signature of that, global cache. What's happening here is Oracle would like to do logging, but it's having a problem because different nodes have different parts of the data, and the rack nodes are having a disagreement over exactly how to do the logging operations. That's where your slowdown is. It's not the storage. And I wish there was a good way I wish someone would do an actual training session on this. You could make a really good 4-hour seminar, write a book, something, because there's so many little examples of this. And when you are the storage vendor like us, we know what we're looking for. We have a whole bunch of people that are field specialists, and they do this all the time. And when you are the vendor and all you see is change, new environments, old environments, people complaining, it's a lot easier to spot the patterns. And when it's just your environment, you don't have the variety of problems that we see. So here's my summary of especially databases, but everything else. Don't worry about the IOPS of the latency if the problem is bandwidth. If you have an IOPS problem, focus on the IOPS. If you have a latency problem, focus on the latency, and consider all of them. Don't upgrade the storage if you don't have a storage limitation. Sorry, sales reps at NetApp, but that's true. And also consider the fact that what you've got is a configuration problem. I mean, you might simply have too few LUNs over on your host, and the host is the choke point for your database. There's so many things that can happen here. And if you don't take the time to really understand it and don't accept the fact that you really do need to analyze what's going on, you're going to overspend and take the risk of buying the wrong solution.